KNN for regression. In the previous lecture, we had seen how to use KNN for classification. We had seen about the KNN classifier. In this lecture, we are going to see how to use KNN for regression. Mainly, KNN is used for classification, but this is a special case in which you can use the same technique in order to solve a regression problem. Let us see how to. In case of classification, we saw that KNN is used to classify the data point based on the majority class among its k nearest neighbors. In case of regression, you apply the same technique, that is, you pick the k nearest neighbors and then instead of doing a majority voting, what do? You take the average value of those k nearest neighbors. It's as simple as that. This is how you do regression. That is, if you have a point, let's say all these points are what you have, and just assume that all these points carry some particular weight or some particular value, which is the final output that you want to find. Let us say there is a new point here for which you have to find the value. For this, what will you do? You'll pick KNN classifier. Let us say your k is 4, then your classifier is 4NN. So in this case, it is regression. So for regression, 4NN, first you find the 4 nearest neighbors. Which are the 4 nearest neighbors? One neighbor is here, one is here, one is here, and fourth one is here. So you picked 4 nearest neighbors. These are the 4 nearest neighbors. Next step is to find the value of each of those 4 nearest neighbors. Let us say the value of this is 3, value of this is 2, value of this is 1, and this is 4. Let us say these are the values. What will you do? You will take average of all these 4. That is 4 plus 3 plus 2 plus 1 whole divided by 4. This is how you find the value in case of KNN regression. Most of the points that we discussed for classifier holds for regression as well. That is, in the training phase, it is very simple. You simply have to store all your data. You don't have to do any computation. In the prediction phase, this is where the actual work comes in. That is, given a new data point, first thing, you have to calculate its distance to all the training examples. So this is the most difficult part as we discussed in classification. And what is the second step we discussed in classification? Let me write here. So first thing is finding the distance to all training examples. What is the second step that we discussed in classification? We have to select k nearest neighbors. So the same thing is the second step in regression as well. The only difference is that in third step for classification, what did we do? We did majority voting. Instead, in case of regression, you take average. This is the only difference. In the final step, instead of doing a majority voting, you take average of all the values of k nearest neighbors. Among all the other points, we then discussed positives and negatives. That also stays the same. That is, we don't have any training phase here. Coming to positives, first positive we discussed in case of classification was that we don't need to do training, which stands here as well. No need of training phase. And what is the second positive? We said it's a non-parametric one, which again holds here as well. What about the negatives? We discussed that first negative is that it is computationally expensive, which holds for regression as well. Why is it expensive? Because of the prediction phase in which you have to calculate distance to all the points and then you have to find the k nearest neighbors. That's what the difficult part is. And what is the second negative? We discussed that it's not suitable for large data sets, and it holds the same for regression as well. If your data set is large, you have to find the distance to all those points, which is again difficult. And the last point that we discussed is bias. So bias as such doesn't hold in regression because here you don't have classes, you have values of each point. So considering that, bias point does not hold in regression. It only holds in classification because you can have different classes. So your data point, if it is majority from the same class, it can affect you. But there is an outside case in which bias can affect. What is that? That is, in case, let's say all your points are concentrated here, the data points. and only 1 or 2 points are concentrated here. Then you want to find the value of the point here. Ideally, this point will be similar to these 2 points, but the value of the points in these areas, this would be quite different. But if you are, let's say, using a 7NN classifier, what will happen? Only 2 points are available here. The other 5 points will come from this, which is quite distant from the actual data point, which would mean you may get wrong results. So in that sense, you can say there is some sort of a bias, or you can say wrong answer or wrong calculation that you would do because of considering k nearest neighbors. Otherwise, this is a very simple technique and very similar to the KNN classifier. The only difference is that in the final step, you are taking average instead of doing a majority voting.